Okay, let's take a look at what you've got done. In the first one here, now all of these, it has to be in the form y equals, so y has to be by itself. So in the first one here, all that's keeping y from being by itself is the 3. And the y is multiplied by the 3, so how do we get rid of it? We divide by 3. So it'd be gone, leaving us with y. Now when we multiply or divide an equation, we have to divide or multiply each piece. So we divided the 3y. On this side, we have to divide each piece as well. 2x divided by 3, well, we just treat that like a fraction. The division becomes a fraction. 2 over 3x. Negative 6 divided by 3 is negative 2. So that equation becomes y equals 2/3 x minus 2. And from there, we can graph it pretty quickly. We start at negative 2. That's our y-intercept. That's the number that's added or subtracted. Then the number that multiplies x is our slope. So 2/3 means we rise 2, run 3. There's our second point. The second equation here, again, we need to get y by itself, but this time what's keeping it from being alone is the 5. The 5 has been added to the y, so we get rid of it by subtracting. Leaves us with just y there. When we add or subtract on an equation, we only have to do it to one piece on each side. So we subtracted the 5 to get rid of the 5. On this side, the only place we can subtract 5 from is the 4. So we still have the 1/2 x. 4 minus 5 is negative 1. So y equals 1/2 x minus 1. Where are we going to start graphing this? Well, negative 1. That's the y-intercept. And from there, the number that multiplies the x is the slope, so 1/2. So we're going to rise 1 and run 2. So from this starting point, we rise 1, we run 2. There's our second point. Starting to look familiar? A little bit? Maybe not. This last one now has a lot of things going on. To get y by itself, we have to get rid of the 3x and we have to get rid of the negative 2. The 3x has been added to it, so we're going to subtract 3x to make it go away, leaving us with just negative 2y. Well, if we subtract 3x from negative 6, what we have is negative 6 minus 3x. Now we need to get rid of the negative 2. Y is multiplied by negative 2, so we divide by negative 2 to get y equals, dividing by negative 2 over here. Negative 6 divided by negative 2 is a positive 3. Negative 3x divided by negative 2 is a positive 3 over 2x. So where do we start when we graph that one? Positive 3. So right there. And our slope is 3 over 2. So from that point, we're going to rise 3, 1, 2, 3, and run 2, 1, 2. There's that line. Any questions? Okay, well, from that, there are other ways we can graph a line. Sometimes we're not given a nice, neat little equation like this. Sometimes we are told, well, let's do something like this. Two hours into an IV, the bag contains 600 milliliters of fluid. The flow rate is set at 150 milliliters per hour. Graph the volume of the bag. Now in medicine, we don't often have a lot of negative numbers, so we're just dealing with that one upper right-hand quadrant of our graph where everything's positive. In this case, now instead of x and y, we're going to have hours, time on the bottom here. 1, 2, 3, 4, 5, whatever. And volume instead of y. And now we have a starting point. Can anybody pick out what the starting point is here? At 2 hours, the volume is 600. So here's 2 hours. Here's 600. We're right about there. So rather than starting at a y-intercept, we can start at some point out in the middle of the graph. It doesn't matter. From there, we are given a slope, even though it's not given specifically. The slope is the flow rate of 150 milliliters per hour. What that is saying is we're changing by 150 milliliters for every 1 hour. Is that a positive 150 or a negative 150? Well, is the volume of the bag getting bigger or smaller? Smaller. In the problem, it's worded as a positive number. But if we're graphing the volume in the bag, it would be negative. Now, if we were graphing the volume that's been infused into the patient, it would be positive. And it's wording it as, going into the patient, but we're graphing the volume in the bag. So if you think about it as related to the bag, it is a negative. So from this point, we're going down 150 milliliters, which would be right here to 450. And over 1 hour. Now you can see here that does not look like it's down 150 and over 1 because the scale on the graph is not the same on each axis. Now I'm going to go down another 150 and over another hour, and I'm going to do it again and again. And if my lines were straighter, we'd actually hit 0. I wouldn't need that arrow on the end because I can't go past 0. At 6 hours, my volume would be 0. And if I traced it backwards at 0 hours, when I first started the IV, the bag would have had to have had 900 milliliters in it. So I could actually trace it back and find that y-intercept. So if I were going to write an equation for this, it would be y equals, where y is the volume, if you wanted to write it that way, equals negative 150x. Do I need the over 1? No, I don't. Plus 900. Where x is the hours that have gone by since you started the IV, and y is the volume in the bag. Every hour, the volume goes down by 150. So what we're going to look at this time now is, what if I give you some information just trying to make sure I make this as accurate as I possibly can. So let's say I give you this graph, and I ask you to write an equation for it. First of all, let's say I've got points A and B labeled here. And I want to know from points A to point B, what is the change in y? How many milliliters does this go up? Well, if this is 250 here, this would be 50, 100, 150, 200. So this would be 100. This would be 200, 250, 300. It goes from 200 up to 300, right? It's 100 milliliters. It increases. From A to B, what is our change in time? If this is 5 hours, this would have been 3 and 6. The time changes by how many hours? 3 hours, right? From 3 to 6. So the slope of this could be determined as 100 milliliters for 3 hours. Make sense? The slope is also a rate of change. This could describe a lot of different things. It might be describing the amount of a fluid infused into a patient. It might describe a fluid output, anything like that. Does anybody have questions on where this slope came from? You're just picking 2 points and finding what is the change in the y and the change in the x. Vertical change and horizontal change. Remember, slope is rise over run. It rises 100 milliliters, it runs 3 hours. What would the y-intercept be here? Well, the y-intercept, remember, is where it crosses this vertical axis, or where it is at time equals 0. What value does it have at time equals 0? 100. So 100 milliliters. So if I wanted to write an equation that describes this line, this graph, I would do it this way. And now most of the time we do slope times x plus the y-intercept. We would write a slope of 100 over 3. I'd leave the units off the equation. Times x plus 100 is our y-intercept. But it might make more sense to some of you if we do it like this. Y equals, it starts out at 100. And then it adds 100 thirds every hour. 100 divided by 3 is 33 and a third every hour. And that's what it goes up. Every hour it goes up 33 and a third. Or 100 units every 3 hours. Let's look at some smaller numbers. Look at just a regular graph with regular numbers. This might be a little easier to understand just with generic numbers in it. On this graph, first of all, where is my y-intercept? -3. -3. 1, 2, 3. My slope. Well, I have this point here. I also have another point there that's on what we call a lattice point or a grid point. So let's find what the rise and run is between those 2 points. So here's a little ramp basically that goes between them. I rise how much? 1, 2, 3. And we run 4. So the slope is a rise of 3, run of 4, 3/4. So the equation for this line, y equals, what's my slope? So 3/4 times x, so 3/4 x. And what's my y-intercept? -3, so -3. So for this equation, what's my y-intercept? For this line, I should say. What's my y-intercept? It's at 2 here, +2. What is my slope? Well, again, I have a grid point there and a grid point here. Drawing in my triangle. What's the rise? It's 2, but it's actually -2 because it's going down 2. Right? And my run is 4. So that gives me a slope rise over run, -2 over 4, which can be reduced to -1/2. Now I get asked a lot, is that a -1 over 2 or is it just a -1/2? And the answer is it really doesn't matter. It's the same thing. Because even if it's a -1 over 2 or if it's just -1/2 like that, we put the negative with the rise. So the positive or negative tells us whether we go up or down. The run will always go left to right. So the equation for this is what? Y equals -1/2 x plus 2. What do you think? Doable? Let's have you guys try one. Find the equation for that line. So the first one here, what's our y-intercept? Well, here's 0, that's up 1, 2, 3. That's actually a +3. Now the slope on this one is the one that a lot of people struggle with. How far do we go up to get from here to here? We go up 3 and we run 4. Now, a lot of people struggle. Isn't this -4? Yeah, -4 is a location, but the slope is talking about movement. To get from this point to that point, we are going 4 in the positive direction. Even though we're starting at -4, it doesn't matter about the location. It's the movement. So that is a slope of +3/4. How many of you had that? Okay. So the equation becomes y equals 3/4 x plus 3. Good. So on this one here, our y-intercept, 1, 2, 3, 4. And a slope, now this time we don't have a second point on an axis. I just give you this point out here in space. So we're going to have to draw in our triangle like that. The rise is 1 and the run is 3. So that's a slope of 1/3, giving us an equation of y equals 1/3 x plus 4. A way to double check your slope, if you're getting confused on whether the rise is positive or negative or whatever, is as you go from left to right, does the equation go up or does it go down? If the equation goes up, it has to be a positive slope. I'm going to give you 3 lines there. I want you to find the equations for those. So let's look at this one right here. What do you get for the equation? Perfect. Y equals 1/2 x plus 2. Our y-intercept here is at positive 2, so that's that. And our slope, we rise 2, we run 4. So 2 over 4 reduces to 1/2. Any questions on that one? Okay, let's look at this one here. What do we get for an equation? Negative 4/3 x plus 4. Very good. Y-intercept is at positive 4 right there. And we go down 4 over 3, so negative 4/3. Yes.
And it probably is because I didn't have a chance to watch your second half of the
Yep.
last session.
Probably.
Why is it negative 4 going up then?
Well, because we're going from this point to that point, right? So to get from here to there, we're going to go down 4 and then over 3.
Okay.
Even though it's a positive 4 that we're starting at, it's not the position, it's the direction of movement. And also, as we go from left to right, that line goes down. Think of it as your bank accounts. Would you want the balance in your bank account to follow a line like that? No, because that means it would be going down, it would be getting smaller. So that means it has to be a negative change. The slope is your change, your rate of change. It's getting smaller, it's got to be negative. Okay, let's look at this line right here. What's that equation? 2x minus 4. Good. Our y-intercept there is at negative 4 right here. And it rises 4 and runs 2. 4 over 2 is going to be 2. That's our slope of 2. Any questions? Anybody have all 3 of those right? Couple?
Numbers, right? But some of the negatives different.
Okay. And that's really the hard part about slope is the positive or negative. Now as we look at the slope, let's take some points. Some days I wish I was a better artist. Let's look at this one right here. Now we have these 2 grid points that we're given here. And so we could find our slope by figuring out the rise and the run. What's the coordinate of this first point here, by the way? 2, comma, 1, 2, 3. 3. Good. How about this one? It's 5. So it's at 8, comma 6. Perfect. 8, 6. So if we're looking at this, how much does it rise here? It rises 3. Very good. Now looking at those coordinates, the 2, 3, and the 8, 6, is there a way we could have got that rise of 3 just from the coordinates without drawing it on the graph? Where, how from? Yeah. The 3 and the 6, the change, the y coordinates is a rise. Makes sense. Y goes up and down, rise goes up and down. Our run then is how much here? Count them, it's 6 units. Is there a way from our coordinates that I could have got that 6? Yeah, the 2 and the 8. The x coordinates, the change in the x coordinates is a run. So the slope, often abbreviated with the letter M, by the way. Don't ask me where that came from. I think it was the only letter that wasn't being used for anything else, to be honest. Is y2 minus y1. That's just the difference in the y coordinates for the rise over x2 minus x1, the difference in the x coordinates. What do the little 1 and 2 mean? Well, so you have 2, 3, and 8, 6 are my two coordinates. I'm going to label point 1 and point 2. So when I go to plug this in, y2 is the y coordinate of point 2. So here's point 2, the y coordinate is 6. Minus y1 is point 1, the y coordinate is 3. 6 minus 3 is 3. That's my rise. x2 is 0.2. The x coordinate is 8. Minus x1, 0.1. The x coordinate is 2. 8 minus 2 is 6. So this is 3 over 6, or a 1/2 slope. Which looks about right on our graph. Rise 1, run 2. So let's look at one where we're just given the coordinates and not given the graph. So again, I'm going to call this point 1 and point 2. Well, it's y2 minus y1. So what is y2 here? Point 2, y coordinate is 8. Minus y1, so point 1, that's the 3. Y coordinate is 3. Good. I subtract that, I get 5. Now, x2 is 0.2, x coordinate is 7, minus x1, 5. Yeah. 0.1, x coordinate is 5. 7 minus 5 is 2. That can't be reduced. It's 5 over 2. Now, would we want to change that to 2.5? No. Our slope is rise over run. So we want it as a ratio. It's just a fraction, improper or not. We want it as just a fraction. So what if we have the points 3, negative 4, and 9, 2. Well, again, we'll call it point 1 and point 2. y2 is 2 minus y1 is negative 4. So I'm going to put it in parentheses just so I don't mess that up. What is 2 minus a negative 4? Positive 6. 2 minus negative 4 is 2 plus a positive 4, or 6. What's x2? 9 minus x1? 3. 9 minus 3 is 6. So we have 6 over 6, which is a slope of 1. Not so bad? I'm going to have you guys try a couple in your notes. There's one. And 2. Try those 2. Okay, so for the first one, if I call those 0.1 and 2, again, you could switch it around. You could do 0.2 and 0.1. It doesn't matter. But I'm just going to go 1 and 2 right in order. On top, what are we going to have? 13 minus 1, which gives us 12. On bottom, what are we going to have? Negative 1 minus 7, which is negative 8. So that's going to reduce to negative 3 halves. Negative 3 over 2. How many got negative 3 over 2? Any questions? Just didn't reduce it? You had negative 12 over 8. That works. So 12 over negative 8. That actually is just fine. So over here, 0.1 and 0.2. What are we going to get on top? 1 minus 5. And on bottom? 4 minus a negative 2. So 1 minus 5 is negative 4. 4 minus negative 2 is 6. So negative 4 over 6, or if you reduce it, a negative 2/3. How you guys feeling? Real talkative group today. Okay, so after 3 hours, an IV bag contains 750 milliliters. Two hours later, it contains 250 milliliters. Find the flow rate. The flow rate is nothing more than a slope. So there's two ways we could look at this. We could just take the words right out of the problem, or we could turn them into coordinates. Now, since I'm the math geek, I'm going to do it as mathematically as possible. I'm going to turn them into coordinates, right? So 3 hours into it, 750 milliliters. 2 hours later, that's not going to be 2, it's going to be 5. 3 hours plus 2 more hours is 5 hours. So 250 milliliters. So the slope will be 250 over 750, or 250 minus 750, I should say. Y2 minus Y1 over 5 minus 3. 250 minus 750 is a negative 500. 5 minus 3 is 2. So that divides out to give us a negative 250 milliliters per hour. Now I realize in real life, it's just 250 milliliters per hour. It's negative here because we're describing the volume in the IV bag. So the flow rate would technically just be 250 milliliters per hour. The other way you could have done that is you could have just said, hey, we had to change a 750 milliliters to 250 milliliters. You could subtract them to get 500 milliliters. Now the volume is getting smaller, so it's a negative 500 milliliters in 2 hours. And then reduce it. Divide it out. Let's say an IV bag initially contains 1,800 milliliters. After 4 hours, it contains 1,200 milliliters. Write an equation to describe the volume in the bag. And then a second part of this, how much is in the bag after 10 hours. So let's do this first part. Let's write the equation. First of all, there's two pieces of information we need for an equation. We need y-intercept and we need a slope. Do we know the y-intercept of this? Well, what does a y-intercept describe? It describes a starting value at the time equals 0. Do we have a starting value here? Yeah. Initially, it contains 800 milliliters. So our y-intercept is 1,800 milliliters. Now our slope is a rate of change. In 4 hours, how much did it change? 600, from 1,800 to 1,200. That's a negative 600 because the volume decreased milliliters over 4 hours. So that can be divided out to be a negative 150 milliliters per hour. The other way we could have done that is we could have gone through the points. At time 0, at 0 hours, it was 1,800 milliliters. At 4 hours, it was 1,200 milliliters. And we could have done the 1,200 minus 1,800 is negative 600. 4 minus 0 is 4. So the equation becomes y equals what? Negative 150 times x plus 1,800. So what this is telling us is we start at 1,800 milliliters and we're losing 150 milliliters every hour. Or we're infusing 150 milliliters every hour. Any questions on where that equation came from? Let's do part 2 then. How much is in the bag after 10 hours? What are we going to do with that 10? Put it in for x. X describes the time, the number of hours. So we're going to put 10 in for x. So we have negative 150 times 10, which is negative 1,500. Plus 1,800 gives us what? 300 milliliters. What do you think? Better than sharp stick in the eye? So much? Okay, well, it's about 11:20 now, so it's a good time to take a break. We'll start up at 11:30.